Welcome to this video on the Automic Automation OpenSSH integration solution. In this video, we will explain the OpenSSH integration and what it brings to the Automic Automation user community. OpenSSH is an open-source suite of networking utilities that provides a secure, encrypted channel over an untrusted network using the Secure Shell protocol. It's a fundamental tool for system administrators and developers to manage remote computers. Instead of using insecure protocols like Telnet or FTP, OpenSSH encrypts all traffic, including passwords and commands, to prevent eavesdropping and other attacks. It includes several key components: SSH, which is the client used to remotely log in to a server; SSHD, which is the server that handles incoming SSH connections; and SCP, which is a utility for securely transferring files between hosts. Extending enterprise automation to OpenSSH ensures full visibility, centralized control, alerting, SLA management, reporting, and auditing. Integrating Automic Automation with OpenSSH allows you to run and monitor OpenSSH jobs from Automic Automation without having to log in to the OpenSSH environment. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other, non-cloud operations. By integrating OpenSSH, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. OpenSSH processes can then be synchronized with all other environments routinely supported by Automic Automation. OpenSSH's role is reduced to execute the jobs. All other functions, especially those about automation, are delegated to Automic Automation. This means that we don't have to log in to the OpenSSH environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to run jobs in OpenSSH. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervise processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of OpenSSH jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workloads. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository: a connection object to store the OpenSSH endpoint and login data for Windows or Linux, and a job template designed to trigger OpenSSH jobs. Let's assume we're automating for 4 instances of OpenSSH. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create an OpenSSH job in Automic Automation for each corresponding process in OpenSSH. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, they trigger the corresponding process in OpenSSH. We're able to retrieve the successive statuses, supervise the child processes in the cloud, and finally generate a job report. In Automic Automation, These jobs can be incorporated in workflows and integrated with other non-cloud processes. The procedure to deploy the OpenSSH integration is as follows. First, we download the integration package from the marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. OpenSSH is a standard atomic agent. It requires at least 4 values to be updated: agent name, atomic system, JCP connection, and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every OpenSSH instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the OpenSSH endpoint. Finally, we use the OpenSSH template job to create the jobs we need. We match these atomic automation jobs to the OpenSSH jobs, reference the connection object, and run them. We're able to supervise the jobs and their children, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the OpenSSH integration. The agent is included in the OpenSSH package, which we download from Marketplace. We unzip the package, which creates a file system agents/OpenSSH/bin that contains the agent files. Based on the platform, we rename the agent configuration file UCXJCIDX and set a minimum of 4 values. The agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to the AE and deploys the object templates needed to support the integration, the con or connection object, and the OpenSSH jobs. In our demo, we will create a connection object. Once we have established the connection to the OpenSSH environment, we'll create a run command job first, then we create a get file job, and lastly, we create a put file job. Finally, we will execute and supervise the jobs. Let's move on to the atomic system. Here, we create connection and job objects with specific inputs that allow us to connect to the OpenSSH system. You see here OpenSSH provide a connection object for Windows and for Linux. Let's open a Windows connection object. Here we specify the SSH host. This is the base URL of the OpenSSH server. The next field is the SSH port. This is the port for the OpenSSH connection. The default value here is 22. The next field is username and defines the user that should be used. The password field is required when you do not enable the use SSH key file field. However, if you activate the checkbox, you must provide the SSH key file. This is the file that contains either the public or private component of an SSH key pair used for authentication with OpenSSH. The SSH key passphrase field is an optional layer of security used to protect your private SSH key. Once the connection object is defined, we can now create an OpenSSH run command job. This job allows us to run specified commands on a target host using SSH connection parameters. The first field we define is the connection. The connection drop-down list lets us select the appropriate connection object. Next, we specify the connection timeout, which defines the time in seconds the job is allowed to complete the commands or script file execution. Optionally, we can check the box for the strict host key check. It activates the host key check, which is a security measure where the SSH client rigorously verifies the identity of the remote server it is connecting to. This means it ensures you are connecting to the correct server and not an imposter. The next field is the JSCH config field. JSCH is a library used by the OpenSSH agent. This field allows you to configure the JSCH library, for example, to enable logging for debugging purposes. We use enable SSH log equals true, as you see here. Then you see the command input type field. It is used to execute commands on a specified target host using SSH connection parameters. It can run multiple commands or a script block. You can select either plain text or file path. With plain text, you can type commands directly. With file path, you can provide a full path to a script file. We select plain text here. In the sudo options field, you can choose either none or sudo. Sudo allows you to elevate your current user account to have root privileges temporarily to run commands. You need to provide the sudo username and the sudo user password in that case, which allows you to run commands with administrator rights, if needed. We use none in our demo. The next field is an optional one, the allocate TTY checkbox. You can activate it to indicate that TTY allocation should be done. The max output size lets you define the maximum size of the standard output and the error output parameters in kilobytes. We select 64 here. The last field is the timeout field, which defines the time that is allowed for the commands or the script file to execute. Once all the parameters are set, let's save and execute the job. Let's switch to the executions view. Let's have a look at the reports. The report contains all the information that the target system sends to Automic Automation when the job has been executed. Following the host name, the system lists all directories located in the specified path, such as c:\users\administrator. These are the directories that are accessible, followed by the end command output. In other words, the information is presented in a way that is easy to break down and analyze for further use within Automic Automation. The next log type is the plog type agent log, which shows all the agent's actions step by step. It lists all the parameters used to run the job and contains the response received from the target system. The next job that is available with the OpenSSH agent is the get file job, which allows us to transfer a file from a remote machine to the host machine. Similarly to the previous job, it requires the connection details, a connection timeout, optionally the strict host key check as a security measure for strict host key checking. The next field is the JSCH config field, where JSCH is a library used by the OpenSSH agent. Now, we come to the specific fields for the get file jobs. The source file path field, which defines the path of the file you want to transfer from the remote machine. For example, we use here c:\ftp files\local. In the next field, the destination file path field, we define where we want to place the file on the local system where agent is running. For example, we are using /root/ftp files/new here. Last, but not least, we can decide whether we want to replace a file with the same name if it already exists in the target folder by checking either the true or false box in the overwrite if exists field. If you select false for this option, the command will fail if a file already exists in the destination directory. The job will attempt to transfer the file, but because the agent is configured not to overwrite existing files, it won't know whether to keep the existing file or proceed with the transfer, causing the job to fail. The default setting here is true. Let's switch to the executions view and go to the report section. Here, the agent log lists all the agent's connection and job parameters that were used to run the job and contains the response received from the target system. It also displays all the JSH configurations. The log shows the initialization of the OpenSSH connection and the execution of the get command file. It provides detailed logs of the background processes, including connection establishment, remote version string, ciphers, and client-server communication. The log also indicates when the file transfer is completed. In our case, it has ended successfully. The report of our get file job shows the transfer of the files from the source and destination of the transferred file. Finally, it confirms that the file transfer has completed successfully. The last job that we present for the OpenSSH agent integration is the put file job, which is similar to the get file job, just the other way around. It allows us to transfer a file from the host machine to a remote machine. The fields are all the same, with the exception that the source file path field specifies the path of the file where the agent is running, and the destination file path field defines the destination path on the target system where the file should be placed. Again, when we go to the executions view and open the reports section, we see the report transfer details, and the agent log again provides a detailed record of everything that happened during the job execution, which can be useful for troubleshooting. That wraps up the demo on how Automic Automation can integrate with OpenSSH to execute and monitor run command, get file and put file jobs. Thank you for watching this video.